Welcome back. SolidWorks 2025, second video about assemblies. So in the last video, we saw how to navigate through the assembly and we saw some methods for explore it. Now we are going to cover how to insert parts and how to make relations for them so they can be constrained. So the first thing is, something nice from SolidWorks is that when you have parts already open and you want to insert parts into the assembly, you're going to find them here listed at the left. In any case, if you don't have any, you start an assembly, and what is going to happen is that you are going to be directed to the browse option. So you can also click here at browse and then find the files in your computer and place them. I already have these parts of the mold that we are working in this one. So when you pick one of them, each of them, you're going to have them floating, let's say. And you can just leave them drop at any location, let's say, or they're going to be floating. But what is preferred to do is to just go and click on the check of the OK here at the left or here at the right. And that's going to automatically place the part at the origin and also is going to be fixed. So the first part that you place is not going to move with that method. And they're going to be coincident with the origin. So that's is like I'm talking about the origin plane of the part having a coincident with at the same time with the origins of the assembly. But this is just in case of you did the part based on my recommendations on the previous videos about how to start the sketch and assembly, going through the process of having fully constrained sketches and of course defined at the origin. Okay, so I have my first part drop in position, and this is the first part, and it is fixed as I mentioned, and I'm going to now insert other parts. So let's say this one, I will insert two more, and I can just with control, or well, I don't need control, I think. No, yeah, I need control to pick many of them. And when I go inserting them, SolidWorks knows that one goes after the other, and just with the following of the clicks, they are going to be in place. Okay. First thing to mention is that here at the left on the model tree, you are going to notice that the first part has an F, and the parts that don't, they are actually floating in the space. So they have 6 degrees of freedom. They can they can be translated in the 3 axis, X, Y, Z, or they can also be rotating with the command rotate component. We can freely rotate them all over the place. So we can set relations in between the parts, so they are not just guessing their position. Of course, in mechanical designs, we need to provide relations that are consistent. So one way to do it, of course, is to go to the mate command here at the top in the assembly tab, third command. And mate command is going to show you all these relations. This is pretty close to, of course, the relations that we used in sketches, where we have coincident, parallel, perpendicular, but these ones are actually dealing with the 3D geometry. So it's not anymore 2D, it is 3D. So we can go and pick that we want to do some coincident mates for this part. and this other part. So that way we are constraining, let me cancel this, we are constraining this part in this plane. So it can now be translated along this plane. And as you can see in here, I can move it, let's say, on X and Y, but I cannot change anymore the C direction. And that's because of that mate. We can also perform concentric relations. So that's pretty usual, having a bolt or a dowel pin or something like that. So I will go to the mate command. And in this case, I'm not going to tell the software what I want to do. I will just pick the geometry, and the software is going to interpretate in between the options based on the selection what can happen with that part. So by clicking two cylindrical faces, we're going to have the most obvious could be, or expected could be, a concentric. So the software is already suggesting that relation. So I will pick on the check, the green check, and I will do it once again for have my part fully defined in the coordinates. So now it has no degrees of freedom and 0 degrees of freedom, actually. No degrees of freedom. No, it's correct to say it has a restriction in all the directions and rotations. Okay, let's do it once more, this time with this other part. But I'm going to use a different technique. It's always using mates, but it is closer to what we saw on sketches, where we pick two entities with the control on your keyboard pressed, and then you release the control, and you're going to have a set of options. So the same thing happening here. I will pick this part, that face, and with the control key pressed on my keyboard, I will pick other face and I will release the control. So I have these options available just for select them. So with that, I'm having the coincident, and now I will do the same with two more holes. Let's do it very quickly. Let me rotate this one a little bit. There you go. Okay, so as you saw, it already had 1 degree of freedom, but now it is fully constrained. So extra to this, there is another tip that is when we want to have the same part being used in another position, we can make patterns. That is the much makes sense, right? Or do a mirror of the part. But there is also the option for copy a part with the mates. But it's not actually a copy of the part, it's actually reusing the same part, but reusing, let's say, the mates that has been set for that part. So I will right click on the part that I want and use copy with mates. Now I will click in this arrow, and now I just need to tell the software which faces to use. The great thing here is that if you have a selection that is being repeated, you can just click here in this check, and now SolidWorks expects me to give the reference for the next mate that is a concentric. I will pick this one. I know that it requires an 180-degree rotation, right? I pick this other, and now I pick on the check. And once more here and cancel for just exit the command. Okay, so these parts are fully constrained, and now we have just pending this one. This one is a slider for the mold. So I will pick this face, control, pick this other, release the control, and pick to have a coincident thing in there. Okay. There are many options for constraining. We have been using just We have been just using coincident and concentric, but of course you can use the tangent, parallel, and other mates. So let me rotate this one a little bit and get it in this position. And let me show you another one that is the width. This one, I use it a lot. For example, this carriage is expected to be center in this sliding movement. So I will pick uh, this face, this face with the control. I will rotate, press again the control, and pick this one and this one. When I release, SolidWorks is interpreting the selections and give me an option. So the option is the command width that I mentioned. So it is like kind of a in between, let's say, the faces. So it's the combination of the faces that gives me the alignment, let's say. So as you can see, the part is just constrained, or it's having a pending constraint, let's say, in the Y direction. So it is free to slide as expected. But there is more. Now let's say that yeah, the limit of this part is to touch this block of the insert. So it is perfectly aligned. Yeah, let's see. Yeah, correct. So it's at this point. And but I want to keep the sliding movement because it's part of the mechanism of the mold. So I will pick these two faces, release, well, with the control, I release the control. And in between the options that I have the option for one mate that is to define a fixed distance, but I want to use the one that is a limit distance. So this one is giving me the chance to say, okay, I want this to start at the minimum distance is 0, and the farthest distance is, if I'm not wrong, it was 20 millimeters. Let's find out. We can use this one at 20 to see if it updates. Yep, looks like, yeah, it's 20, or maybe 20 is too much. Oh, okay, let's accept this for now. We can explore it later. Oh, it was a little bit less, but it's okay. So now when I drag my part, I'm not able to go out of this limit. So the mechanism can be represented sliding the part itself, and if there are other parts related with this one, also are going to move based on the degrees of freedom. So this is what I have for this video right now. In the next video, probably you're going to find more information. Keep this extending this basic tutorials, basics on SolidWorks. See you there.